Okay, let's go. It's a super great pleasure to introduce you to Sara Mortara. Oh my God, why this accent? Sara Mortara. You can say in your accent, no problem. It's the very first time I have the chance to introduce someone that is about the same cohort of my PhD. So we both did our PhD at University of São Paulo in ecology. And she looks younger, I know, but she's about the same age of mine. And I know many of you will think that Sara is a computer scientist. You realize that, but she's actually a biologist, which is pretty cool, right? Sara got her bachelor degree in biology at the University of São Paulo in Piracicaba City. It's another city, not here. And then she got a master's degree in ecology, conservation, biodiversity from Universidade Estadual de Santa Cruz, which is in Bahia, right? Is there anyone from Bahia here? Yeah. And she also earned a PhD degree from Universidade de São Paulo, University of São Paulo, where I did as well. Sara's expertise is on statistical models in ecology, especially in metapopulations and hierarchical statistical models. And she worked a lot with fern populations, right? Although her computational abilities are amazing, she did things with fern, which is amazing, right? Sara is a member of the Our Ladies in Rio. Oh my God, I keep changing my accent. And a co-founder of Libre. So Libre is called Laboratório Independente de Informática e Biodiversidade e Reprodutibilidade em Ecologia. Do you all understand what I mean? Okay, great, because it's a great name. And it's a group of researchers that were worried about making science open and reproducible. Is this the word? Reproducible. Oh my God. We don't want to reproduce in the sense of reproduction. Okay. Currently, Sara is working in the private sector, developing codes to solve problems of how make the priorities for conservation of the biodiversity. I think that's it, right? Am I correct?
Yes.
Do you want to add something?
No, I will add some. Oh my God. I will. Oh, thanks. That's better, right? Okay. I will probably add something more while I'm explaining the course, but
great.
Thank you so much, Flavia, for the kind introduction. It's a great pleasure to be here. It's been a while since I don't come to São Paulo, and this course is super special, and we are very happy to be here teaching. Gui, can I put on full screen? Oh, perfect. Okay, so today is the first day of our scientific computation course, and I'll be teaching this together with Andrea Sanchez Tapia. We work together. We've co-founded Libre, and this is Andrea. I'm here. I'll be teaching the first 3 weeks, and then Andrea will come to teach the following 3 weeks. So we have to explain a little bit more about this course, because we were invited to teach an art course, and that happened also in the Rio de Janeiro Botanical Garden. We taught for 2 years at a graduate course, a similar course to this that we call Data Analysis Projects Using R. And they asked us for an R course, and we delivered a course with R and Git and version control and Markdown. And we were actually we wanted to think about what are the skills that we think it's important for a data scientist or a person doing data analysis in general. And it's much more than R. And we think it's R or any computational language is super important, but version control is crucial, and reproducibility is very, very important, and it's a base for us. And we learned those other things that are not R by ourselves. So we wanted to create a course that embraces general tools that are desired for doing data analysis. And that goes beyond R. And that's why this is not simply an R course. And we'll be all the time linking code with what we call scientific workflows, and more importantly, reproducible scientific workflows. So that's why we asked you if you were familiar with some of these things like R or version control with Git, LaTeX. We will not talk about LaTeX, but we will talk about R Markdown. And it is another way to build reproducible manuscripts or reports. So during this course, we divided the course in 4 modules. And the first one, it's the basic tools. So there's the R introduction class, which is today. We'll talk about Git and scientific workflows, exploratory data analysis, data manipulation, data visualization. There's the statistical modeling module, in which we'll talk about linear models, especially, and model evaluation. And we will talk a bit about generalized linear models. And from that, we can scale up to more complex mixed models with more complex random structures, error structures. But we will not cover that, but you can easily go from that to beyond. This module will connect a lot with the class that Glauco Machado is giving. I don't know if it already started, but statistical modeling starts with a hypothesis, so there's no way to start any differently. So we'll talk about implementation of linear models, but keep in mind that hypothesis is the base of everything. There's a biology and ecology toolkit module, and we will implement 2-species dynamics, things that you are seeing with Roberto, spatial analysis, biodiversity, databases, diversity metrics, multivariate analysis, predictive modeling, which could be in the statistical modeling module as well. And we finished the course with the open science module, and we will talk about creating reproducible reports and manuscripts in general. And we'll talk about open science, open methods, and community. So this is the overview of the course. And I'll be covering basically the basic tools and statistical modeling part, and Andrea the last 2 modules. So today we'll talk about R and RStudio. I have to explain something here about RStudio, because there are several editors from which you can run R. I had my favorite, and it's not our RStudio, but for teaching purposes, we choose using RStudio because it connects easily with Git. It connects easily with Markdown, and it minimizes the error possibilities. So we are only dealing with R errors or RStudio errors. So that's why we kindly ask for all of you to adopt RStudio, at least for this class. When this course ends, you can go back to your favorite editor, but please, let's follow this. If you're super advanced and know how to do everything using your favorite editor, go on. But just make sure that the only thing that we want is that we always know from where we are running a script. So that's the 101 part of this class. And it's to run a script from a specific location. We will never open R and start running things without choosing in a very informative way from where we are running the code. We will also end the day reading an external file in R. So this is what we have for today. So, and why R? I mean, there are other computational languages, and R is not the best, but that's totally arguable. But we defend because of what I will list here. And the first thing is that it is a common language for academics, especially in biology and ecology. People are not very familiar with computation, and learning R is easier than learning other languages like R, like C, or things that are harder than that. And it's a common language. It is widely used in ecology, so that's something. And it is free software, open and free. It is free, it doesn't cost anything, and it's also free to be used and modified by any means. This is one of the pillars of open science, and we value that, so that's something important. It is script-based, so when I was in grad school, there were a lot of click-based software to make statistical analysis, but that's something that it makes harder to create reproducible workflows. So scripts are better to guarantee reproducibility. A script per se does not guarantee reproducibility. We will talk a lot about this, so that's why we want to always work together with a script and reproducible methods. It's easier to scale up your analysis if you're doing things repeatedly. Working with a script is much better. It can be very transparent for you to track errors, for others to track errors. And it's a great way to learn about methods. I mean, nowadays it's super common for people to publish their scripts in the supplementary material of their papers. And that really adds something to the understanding of the methods. R is interdisciplinary, so it's very used in ecology, but people from digital humanities use R a lot, and physics, and I mean, you can find basically all kinds of packages in R. And one thing that is very interesting is that there's lots of code that is written by area specialists. So if you think about statistical modeling, there's Ben Volker is a person that publishes a lot about developing new methods in statistical modeling, and he's also the author of several packages in R. That's super common in ecology. And the idea of R is that behind the language is to actually be a language that bridges the gap between the user and the programmer. So as we become advanced users, it's easy for us to start programming something and creating packages. Andrea and I, when we started creating packages, we went crazy and we wanted to create packages for everything. But that is something. And you easily empower yourself and the community because you can create things with the language. It has great communication with other tools, so you can write manuscripts using R Markdown. You can create presentations such as this one. This is using an R package called Sharingan. You can easily create apps and dashboards. And it also communicates with other programming languages. So there's a package called Reticulate that runs Python scripts inside R. That's super. I have used that because I work with a guy that writes code in Python only, and I wrote in R, so that's good to communicate things. R has great graphic capabilities. So it is a powerful tool to create graphics. It can sometimes be annoying to be create a graphic exactly how you want, but it is a powerful tool for that. And it has a huge official support. You can find help in documentation, in mailing lists. This may sound old school for you guys, but there are tons of mailing lists from any topic that you can think about, and they are very active, and the specialists are always replying to the questions that people have in the mailing lists. Ooh. And the thing that I think it's super special about R is that we have an active and welcome community. Besides the email list, there's Stack Overflow. We have the R Studio community. We have Use R groups. We have the R Ladies chapters. R Ladies is an organization to improve gender diversity inside the R community. They are super active. There are local chapters in many towns around the world. So São Paulo has a chapter. Rio de Janeiro has a chapter. Buenos Aires has an incredible chapter. They're always organizing events. There are many events, online events, all over the world. You can jump in Our Lady meetup in Bangalore and learn something. And that is something that it is important, and we like to build communities. And this course is not taught by one person, it's taught by two persons, because we are like that. We like doing things together, and we learn a lot together. So we expect that you can also create a sense of community among yourselves and learn together during the course, and take advantage of the whole structure that we have. R has a modular structure, so.
Hi.
Hi. Yes, feel free to interrupt anytime, please.
Is it working? La 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 la. Is it? Is it? Yes. Oh, you mentioned the integration with Python. I'm rather interested in Julia recently, but I do not know much. Is there a reasonable integration between R and Julia?
I do not know, but we can check. I would be happy to check that.
And I can ask this later.
No, you can ask now. Go ahead.
Since I saw the name Libre for the program, I got very excited because it probably shows that you have a stance regarding this as a group of research regarding the use of Libre software and free software in general. Do you?
Yes. Well, currently I work in the private sector, and my company uses Windows, and that's really hard for me, but we keep using our studio, at least R in our studio, and we have a server with Linux. But when they were creating the server, they were, oh, okay, so we will create a Windows server. And I was like, no, please do not do that. But we are super pro using open source, open software, and open methods and open community. Andrea is the queen of the open science. And we will end the course with a discussion about open science and open methods. But when we created Libre, we were in between jobs and we didn't have affiliation. So
you had the freedom to do it.
We had the freedom to create, and we were teaching a lot. We were involved in a lot of initiatives of teaching outside academia as well. So we had to create a group. It started with a group of the two of us. We have another collaborator, but it's hard to do science when you are not officially at a university. So we started Libre because we needed affiliation, and it didn't help much, but it helped for us to do something and use that, and we adopt, and I sign things with Libre, and that's it.
Okay.
Okay, so R has a modular structure. We have a base installation. All of you managed to install R? Yes. Great. So when we install R base, there are a few packages that are included with the base installation, and if we need any other specific package, we need to install it, and all the packages are maintained by the R core development team, so it's not by one person, there's a team doing that. All the other packages are created by the community, and they are hosted in CRAN, the Comprehensive R Archive Network. This is the official repository for our packages. There are also other packages that are hosted in the bioconductor, for instance, on GitHub, on R Open Science. Maybe you already install a package from GitHub. There's a specific package from where you can do that. All the packages that we created, we just leave it at GitHub, and people use it already. CRAN, it is picky, and you have to follow a lot of rules to leave a package on CRAN, but it's super possible when people do that. When we install a package from CRAN, we can use the function install.packages and the name of package inside. And we will run R using RStudio, as I said. When we are using RStudio, we have a session where we have the script. In any editor, we will have that, a script and the console, and where the code is actually run. The script is just the script of what we are writing. I will show you how we will do that. So I'm using here RStudio server. This is a web page. This is what I do for my work, but it works exactly as the RStudio that you have on your desktop. I think it's a bit hard to see, right? Okay. So when we are running R, you can change in the global options part, the color of the R session that you want. I like it dark, but that's something that I do. You do whatever you feel comfortable with. So we will always use R from the script, and we will run scripts.
Just change your microphone when you're here.
Okay. O que eu tenho que fazer? Can you all hear me? Yes. Okay. So we will write code in a script, and we will run code here. When you start R, it will say what version you are, with version bird hippie, and it has a welcoming page saying that R is free software and comes with no warranty. Oh, let me. R has many contributors, so you can check how you can cite R. Oh, citation. We will never do what I'm doing right now, which is writing code in the console. So to cite R in publications, you have like the BibTeX entry for that. If you want to cite a specific package, you do citation with the package name. So I'm here, like I just opened RStudio and I started. That's not how we will do things. So we'll always, if I ask here where I am, it is the get WD. So I can get in which directory I'm running RStudio. I'm running RStudio in home Sara. This is what you will get, like the defaults to run R from your home. So we are doing a project, a data analysis project. You don't want to like run scripts and create things in your home or anywhere. You want to run a script from a particular location. So that's why we are using something that is called RStudio projects. And I left in the web page. Let me come here. Oh, here. A link where you can download a zip file with, you can do that in a few moments from now, but you will download this zip file and you will unzip that wherever you want. So I did that. So I don't want to be in my home. I have a data, my personal page, and I have a folder for courses, and I unzip it here, and I have an R project here. I will open this project. The project comes with the icon of a cube with R, and I'm opening, don't save. I'm opening from the file section because I want to change my location. So I'm here right now. There's it shows that I opened an RStudio project, and now if I open a script and ask, where am I? I'm in Data Pessoal Sara Courses 2022 Scientific Computing Intro. So I choose a location from where I will use R in this section. So every time we are doing a project, it could be a good idea to create an RStudio project and run R from that location, or you can just run R from the location of where your script are, but never, never, ever like open RStudio and start doing things in the area that you open without actually choosing where you are.
It's working, okay. How do I create a project? Hi.
No.
How do I create a project?
Okay. I will show that in a bit. Okay. We have the zip file with a project that was already created, but good. I will show you how to create a new project.
Okay.
Hi, my name is Andriele. I usually save only the script. I don't create a project. Does there any problem?
That is not a problem, but during the course, we hope to convince you to adopt the idea of using an RStudio project, or at least, because something that we use, I asked it, get WD. There's a function called set WD. I don't know if you use that, but you can use that to set from where you want the R to know that you are. That is something that people use, but that is a bad practice because the path in your computer is specific to your computer. If I want to run the same script, imagine that I want to run your script. I need to be able to open the script and run everything in my computer. So I have to find the paths for input data or know where to save the outputs of the code, if any. So we will not use set WD. We will use the project to tell R where we are. And that way we can have like compact and self-contained project structure. And you can run in your computer, and I can run the exactly same thing from my computer, and it will work. That's our goal when we talk about reproducibility. We are able to reproduce from the beginning to the end of a data analysis workflow. So when we start, you have to tell R from where you will be working, so it can understand input data, where you want to save the outputs. So if you run, like I did, get WG, it will tell where you are. The default is home, but you can tell where you are by using set WG, but that will only work in your computer, and that's why we don't do that. And a better way to do that is open, like, your R script. You can open your R script in a project folder, or your RStudio project, which we will use. So imagine that you are writing a manuscript using Word. When you want to go back writing your manuscript again, you do not like start your day, open your computer and open the Word program itself. You go to the folder where your manuscript is and you open your manuscript. That's what we will do when we are using the RStudio project. We will not open RStudio, we will start opening the project that we are working. Projects, any data analysis project, are better organized if we use one folder per project and subfolders within our working directory. Something that is super important in data analysis is never to modify your raw data. You always read raw data. If you modify the data, you will write processed data in a different archive. You will never overwrite raw data. And instead of using, you can read a file in R using the absolute path. So it's home, Sara, my project, data, blah, and that works. But if we are in RStudio and it already knows where we are, we can use relative paths, and that's what we will use. And using relative paths is a super important step to reproducibility. So the dot means here, the directory where you are. So if you have, in your project structure, a subfolder called figs, if you want to write a fig in that folder, you can just tell dot figs and write in the file. And we'll avoid using things like absolute paths, okay? Never, never, never. So in this session and in the following section, we will adopt a standard for a project structure. This is actually real. We actually use that structure and it helps a lot. So in the zip file that you will download, there will be this structure. Not all the files are created, so you won't have right now the processed folder, for instance, because we haven't processed anything. But we will have a data folder for data, obviously. We will make a distinction between raw and processed data. We have a folder called docs, from where we will write reports or a manuscript. We have a folder for figures, called figs, an R folder for scripts, a folder for outputs, and something that we called README. And this is as it is, go read this. And this is super important for documentation. And that's really good when you are in a collaborative project, but it's also good for yourself in the future. So the thing about open science and being a good collaborator is a good thing for the others, but it is amazing for yourself too. So it's something that I adopted from every project. I have a README page and I describe the project structure. I describe why I'm doing that and what are my goals, and that can change to time. And this is basically a daily journal where you can like add and change things. And it is the first thing that you see in the project. And that is super useful. It is super useful as well for data folders, because sometimes like we download the data and we put that in the raw folder and we forget from where we downloaded the data, when we downloaded the data. So keeping track of metadata is super important, and we will use README for that. And like I like to have like a README inside basically every folder that I have, but at least in like the start of your project, you have to have a README. So you will do what I did here when I was showing you. When we are creating a project, I will show you first how to create our studio project from scratch. But you will create we use the RProj file. It will tell your RStudio from where you are. So you will unzip the zip file that is in the main page of this class and open the RProj and run getwd, and you have to be where you unzipped your folder. I will just show you first how I can create a new project. You can go in this icon here, and create new project. You can open a project that already exists. I have like many projects that I use. Or you can create here new project. And well, I don't want to save this. But it will ask if you want to start in a new directory or an existing directory. I will click that and I will browse. I will create like here. Not actually here, I want to create in a folder like test. And I will choose here. And I will create project. And now I switch it here, I'm in the test project. If I run here, I'm in Sara courses test, where I just created. I can navigate through my projects from here. So this is the project that I want to be at. And you can open the R folder and open the one intro script. This is something that we'll talk more in the scientific workflow class, but it's a good practice. We'll talk about a lot about good practices. It is not something that we invented from our heads. It's something that people, communities share as good practices. And that's why we say that a lot. So we have like a header in every script saying like, this is the scientific programming course, this is the class 1, introduction to R, this is just an introductory script to play with our data types. And then we can follow. In RStudio and in other editors as well, you can have that functionality. If you use at least 1, 2, 3, 4 minus sign, you create a session entry. And you can navigate your script through these sections. This can be useful if you have a really long script or even a short script that you want to divide into sections. We use that a lot, and that's why like you can see those things here. But right now you should download the zip file, open the R project, and run getwd and be in the directory that you choose. So everyone got there? Okay, awesome. Yes, please.
I wanted to ask you to repeat it again, please, if you can.
I'm sorry.
How to open the project?
How to open. Oh,
Yes.
okay. It's just that I'm inside a server. So imagine that you are, I'm using this. Oh, I have to talk a little bit about this. So in our studio, in addition to the script and the console tabs, we have other panels here. In this one, I don't have anything, I didn't create anything in my environment, so my environment is empty. But I have I can have the history of what I already run in my R, so far this. And this is the main things here. But you have this panel with files. This is like any file navigator that you have in your computer. Because I'm running R from the server, this is the only interface that I have in the server, so I'm navigating from this file tab, but you can open your R project from the file navigator in your computer. You open here in the folder and you go from where you to where you unzipped your file. But here I know that I unzipped my file in this folder, so I went there, Pessoal, Sara, Courses, and the folder, and I will just click in the project here. Oh, now I'm already in the project. So, well, let's go to the test. I will switch to the test here. And yes, I want to open. I don't want to save anything. And so that one way is to just click, if you want to open your math script that you are writing in the Word, you would double click in your file, you will double click in your R project file. That is one option. And the other option is that if you have your RStudio open, you can just navigate from the project panel, icon here, and go to the project or either open project, and I can navigate to where I want. We also like relative paths because everyone has their own way to organize their computer, and every time I'm teaching and I'm showing my computer and my paths, feel like I'm showing how I am from inside. But it doesn't matter anything from the project to the upper level. We will only care about what is inside the project.
So just to see if I understood it correctly, creating a project then is a way for you to not use the get set work in that directory because of the mess with the path. So you just have to click.
Yes, you won't have to use the set WD because it's already set.
Okay, thank you.
So I'm opening the project again. I'm opening the first script. This is also something that we like to adopt. We use numbers for scripts. So if you open an R, all of our scripts will be in the R folder. So imagine that you are doing an analysis with several steps. It's advisable to create a script for every step. That way things are kind of modular. And if you use numbers, it's easy check and see what is the order where you should run your script. So we like that. So let's get back here just to see if I'm not missing anything. Oh, something that is the project structure. I think that I skipped a slide with something that, no, that's from here. Okay, so we will start talking about R finally. When we create an object in R, we use the assignment operation is the menor, smaller than, minus is the assignment operation in R, and it creates objects and saves objects in your workspace. It has a shortcut that is super useful, Alt and minus. And if you override a particular object, it won't affect any other objects.
Do you hear me? Yeah. What is the difference between that one and the equal sign?
It is the same. If we want to be purist, I guess, we will use that because that it can easily separate from the equal sign that is used inside a function. I like to use that to assign objects because it makes the code easier to read, but the equal is correct as well.
Sorry, I know nothing about R. So there's no difference of, perhaps you're pointing to the same place with equal and with an assignment you're making, creating two different things. There's no difference between those.
Exactly, exactly. When we are creating objects, there are a few tips, like don't be generic, like create an object called A. And don't begin with a number or a symbol because it won't work. There are a few forbidden words, like you don't want to overwrite a function that already exists on R. Like there's a function called min. If you want to create an object called min, it will work, but it's not advisable because it can make a confusion for yourself at least. We will talk about coding style further in the course, but be consistent with your coding style. If you like using like upper script for naming objects, stick to that. You can use dots. It's recommendable to avoid dots, but if you like, okay. And it's usually recommended when you are created a function. Functions are usually verbs and objects are usually nouns. That is something that is a general rule and it's good to follow. Like the function get, WD is a verb. If you are creating an object, you can use a noun for that. You can see which objects are saved in your workspace by using ls. It will list everything that you have. And R creates objects that occupy the memory, and the objects are created in a workspace. The workspace can be saved, but as we like to say about good practices, we won't save, I'm forgetting about this. We won't save the workspace, okay? Because every time we will open our R, we want a clean session. We will never start R with objects that you already have on your workspace. Imagine that you are doing an analysis and you are calling like your data. There are people laughing here because yes, we all did that. And that's why we put those things in this course, because been there, done that. And you already have a data in your workspace and you are starting a new project and you forget that you already have a data and you want to check a column in your data and you don't find because you are in the wrong data. So we'll never start working R with loading in a previous environment. You can lose track of what you created and how you created the objects in the workspace. So don't save the workspace. And I want you all to go to RStudio in Global Tools, Global Options. And we will uncheck the option. It is super, I don't know why they do that, but the default is to always save the workspace. But we will uncheck that, so we don't want to restore our data, and the workspace is saved as our data. We do not want to restore our data into the workspace at startup. And in the option save our data on exit, never. Okay, so let's all do that. Tools, Tools, Global Options. Let me get, found it? Everyone, let me go back there. You go here, Tools, Global Options, Restore, and you have to click Apply, and then Apply, and then OK.
Excuse me, but when it's working? It's working? Okay. When you have like a model that it takes a lot to run and you save that, it's good to save?
Yes, that is something that we will talk about later as well. But yes, the only time that you save your workspace is like when you are doing, for instance, a simulation that takes hours or days. And then, yes, you can save like your workspace or specific objects that you need for later. But in general, if you have like a script that like it takes seconds to run, like do not save your workspace. We will save the script, the inputs, the outputs. If it is reproducible, you can like run again and create exactly the same thing. Okay. So functions and arguments. So we will like create here like random objects. Like we are assigning to an object called weight, underline kilos, and this is the square root of 10. A function in R is always followed by brackets, and everything that we put inside the brackets are the function arguments, okay? And we have the function round. You have the function args, from where you can like ask what are the arguments of the function. If you know the name of the function, it is a good thing to like check the help page of the function before using, or if maybe even if you're familiar, there are functions that are tricky, and every time we are consulting the help. So if we need to check the documentation, we can use the function help and the name of the function, or question mark and the name of the function. And we can check the structure, and we'll see the description, usage, arguments, details. If you don't know the name of the function, you can use 2 question marks. And imagine that you want to perform like a Kruskal test in R. You can use 2 question marks and check if there's a function that does that. You can search it, Google it, or go it, whatever you want. The arguments of a function, they are coded in order. And sometimes they have default settings. And you can either use the arguments in order, or without naming them, or you can name the arguments, and when you are naming the arguments, it doesn't matter the order.
It's up. No, it's not. What is an argument? What is an argument? Like
Argument.
Yes.
Every function it is basically how you describe a function. Every function has to have at least one argument. It is what will be inside the brackets, okay? I will open R and I will run code, and maybe it will be easier to understand. But every function performs a task. And to perform a task, it will receive something and give back to you something. And what we will do, and that something is an argument. There are different data types in R. So here I'm creating a vector called animals. The C function is a function that concatenates things. So I'm concatenating 3 characters. Every time we have a character inside R, we have to use brackets. And we here have like a vector with animals, is built with characters, and a vector that is numeric. I'm concatenating different numbers respective to the weight of the animals. If I ask the class, there's a function called class, and it receives, the argument that the function receives is an object. Any object that you have inside your R section. If you ask the class of that vector, it is character. If we ask the class of the weight vector, it is numeric. So we have character, we have numeric, but we also have logical and integer and complex and others as well. So let's go to R, because I think it's better than showing the slides here. So I will follow the script. You can do the same. You can open the intro script and we can run together. So we have here the square root of 10. We are here in the script. If we want to send something to the console, we will use Control Enter. And Control Enter will send the line, a specific line, to the console. So square root of 10. I'm rounding 3.14. I'm asking what are the arguments of the function round. It is a function. It has an argument x and the argument digits. So that's why we prefer using this to assign objects, because inside a function, when we want to specify an argument, we will use the equal sign. So inside a function, we will use equal, and to assign objects, we will use this sign. In R, you can use like Alt and minus, and it's a shortcut for doing that in RStudio. So I'm creating the vector animals, I'm creating the vector weight. If I use the ls function that will list everything that I have in my workspace, I will have animals and weight. Here in the environment panel, this is interesting because it shows everything that it is in your workspace. It is basically what the list function is doing here, but it shows the names and the basic structure here. And, I skipped this one. The class of animals is character. The class of weight is numeric. If I can see what is inside my object, I can just like call the name. So I created a vector animals, and this is how R is seeing this. If I want to like grab the second element of my vector, I will use this and a number. So that way, I'm selecting the second element that is red. If I want to subset, like the third and the second, for instance, for no reason, I will use the concatenate function inside this, and I will select both 3 and 2.
Teacher,
we
So I have particularly difficult to differentiate a character and a string. Like, what is the difference?
a character and a string. It is, I would say a string is a character. It is the same. Inside R, it is the same.
Okay.
It doesn't have a difference.
It is because sometimes it's printed that like there is something wrong with the character, and the other times with the string. So I don't know how to differentiate. But okay.
Yeah, it
same.
is the same. It is
Okay.
the same for R.
Thanks.
So
Sara, that console is a simple bash console. What?
no, it's an R console.
Okay, but you have all the bash functions like.
No, you don't. Like, if you want to know, like, I have here a terminal, for instance. If I want to know, for instance, where I am in the terminal, let's go back to this. It's PWD,
Okay.
home Sara. Inside R, we have an R function that does that. That is get WD.
Okay. I just
So-
thought because you did an LS and everything worked, so I thought perhaps it would be a bash. It would have
No,
bash
it is
inside.
like people that created R created this console that is an R console, and that it runs R code.
Okay, it's
And teacher, we were wondering how we could concatenate two vectors, that the concatenate could do that.
I'm sorry, I didn't.
Sorry, it's
No.
working now?
Yes.
Yes, we were wondering, like, the concatenate could, like, concatenate two vectors.
Yes. Let's try that. So if I want to concatenate, the thing is that a vector, it is, you can concatenate, for instance, animals and animals again. I'm repeating it. If I concatenate animals with weight, what happens is that right now my numeric vector, a vector can be only one type of class, okay? So if I'm concatenating different classes, it will always convert to a character, okay? If I'm mixing with a character. Yes, that is a different type of object, okay? So a vector, it's like one line. We will create data frames that are like more complex structures, such as a data table that we would have. So we are subsetting here using numbers, but we can subset also using a logical string, okay? A logical string is a string made of like true and falses. And if I do this, I have an object here, weight, and I want the first and the last one, 21 and 54. So that's what I get if I use this. But I mean, we do not like use this thing directly. We create like a logical string asking something, right? So imagine that I want only the weights that are higher than 35. So that's what this will result in a true and false vector, and I will use this to subset my vector, okay? We will use logical operations to do this instead of doing like writing trues and falses. We do not do that. So I have here like more animals. And I want to see which animals are in more animals. So if I'm asking this, the result is true and false. And if I want like to subset only animals that are in more animals, I can use this, okay? There's something that is like regular expressions are ways to assess parts of strings in any language. And the way that we do that in R, it is using the grep function. And this is like super cool to use. Like it's something that it helps a lot, but we never know how to use regular expressions. We always have to Google it. So imagine that I want animals that this stands for starts with. So I want the animals that starts with D in more animals. So this will get me dog and duck. The result of this grep is a logic vector, okay? Because this is the grep L. If I want the grep without the L, it will return the indices. If I use the argument value equal true, it will return this. So this is the same as doing what I did here. R has a way to recycle things. So we have animals, it's a vector with 4 elements. We have more animals, it's a vector with 5 animals. If I want to see if they are equal, I will get here a warning message because the longer object is not multiple of the object of the shorter length. What R is doing here, if animals is shorter, it will recycle. So it will test here. Mouse, rat, dog, cat, and it will use mouse again to test against the other one. But it works, but it gives you a warning. So every time, if you do something that R doesn't understand, like let's try grab blah, I get an error because there's no object blah in my environment. This is an error, so the command is not running. Here, yes, I run the command, but something is wrong. So every time you have a warning, please check. Do not ignore warnings. We can check the difference, a way to check the difference between two objects, they are of different lengths. We can use the setdiff function. So it will tell me the difference between animals and more animals. Let's talk about non-available data, or NA. I think this is still like hard to see. This is better.
The function set difference will return a vector
Yes.
if I work with a data frame too?
It doesn't work with a data frame.
Oh.
It will only work with a vector. So the way that we can assess, I talked about the help, but let's do this. So if one question mark, we will open here. So here's a function that it is actually a set of functions. So we are not only assessing here the setdiff help page, it has a common help page for other functions. And the arguments are the same. So the arguments are x and y, and they are vectors containing a sequence of items with no duplicated values. So that's how you know if the function will work with a particular object that you have.
If I work in a data frame and want to see some difference in a row of columns, I can use
Yes. You can like select only a column or a row of your data frame, and then you have a vector, and then you can use that. So here's the help page. It is really good to be like familiar with that. So it will tell you from which package it is. It is from RBase. It has like the name of the function or groups of functions. The usage, the arguments are all listed here. And the details, there are a lot of like other explanation about like the value. There's sometimes this also, so you can check like other similar functions and always examples. This is super helpful. Okay, let's keep going because we still have a lot to do today. So we have here weights, and here I added an NA. This stands for not available. So I have data that I know, and I have something that I do not know. So I'm measuring something, and the experiment went wrong. I couldn't measure one rat, whatever. And I want to check the mean of this vector. It will return NA because I have one NA in my vector. If I ask for the maximum value, it will do the same. Several functions have this same argument, na.rm. This stands for remove the NAs and then do what you have to do. So if I use the argument na remove with as set to true, it will now calculate the mean and calculate the maximum. So we have other data structures here. Let me just go back to the slides to see if I'm not missing anything. So we...
Excuse me.
Yes.
I only had one question. When you set like NA remove, you are not like removing from the original...
Yeah, yes.
Okay.
You are only removing to do the operation that you want, okay?
The vector
will remain the same. There are ways, in the end of this script, we will remove NAs in a table, from a table. We will see that. We don't have much time. I will speed up a little bit, okay? Because I want to run the rest of the code with you, but you have the material, so you can, when you get home or anytime you want, run the entire code and with like in your own time and understand, like, and just play more with this objects and things. So this is different ways of building logical vectors in R. So we can test if something is equal. As equal, you can use to create an object. When you want to see if something is actually equal, you use double equal. If something is different, is exclamation point equal. You can check for inequalities. You can check if something or is the pipe sign. An intersection is E. Belonging, as we saw, is in with the percentage sign. And difference between sets, you can use setdiff for vectors. And if you want to negate things, you will use the exclamation point before something. So if you want to see if something is not inside, A is not inside B, you can use the exclamation point. Microphone.
Yes.
And using equality, like if we have two vectors that has the same items, they would be equal or not?
If they have the exact same items, yes.
Okay. And will return true.
Yes.
Equality. Okay.
Yes. So we can compare vectors as we did using in. We can use the equal sign as we see. We are comparing and it is recycling because they are not the same size. We saw what happened when we have missing data, NAs. And we have different data structures. We saw a bit about vectors. They are linear arrays. They have only one dimension and only length. We have factors. Factors are vectors that represent categorical variables that have levels. This is super useful when we are doing like experiment, for instance. Like it is the equivalent of a level of experiment. Sometimes we want a categorical variable to be a factor. We have matrices.
Microphone is not working, so it is not for the recording. Yes.
I'm sorry. Now you are hearing me? Okay, I think that I...
Yes, yes, yes. Now the microphone is
okay.
on. Okay.
Thank you for that. I think that I No, I switched it. It is.
Yes, it is on now.
Yes, but I had to.
I don't know if it's oscillating.
Yes, I. Yes, let's do that. Okay, thank you. Okay, so we have like these different type of data structures, vectors, factors, matrices, if we only want like one type of data. Data frames, if we want to combine different type of data in the same table. We have our arrays. They are similar to matrices and data frames, but they are three-dimensional. Imagine like an Excel spreadsheet in which you have like different tabs. This is the structure of an array. We also have a list, and an array, it is three-dimensional, but all the dimensions must be equal. And a list, it is literally a list of anything. So you can have like the first element, a vector, and the second matrix, and the third, a data frame, and whatever. You can combine different sorts of data. We learned how to assess the help of a function with the help function. There's also some packages that they have like their own documentation, similar to like an article actually. And this is called vignette in R. And some packages have really good documentation. We have lots of community forums, community Slack as well. Slack is a tool that you are using here for the course, and it is super common in data communities. Stack Overflow, and this thing called task views. It is in R, and it combines, there's like an environmetric, for instance, task view. It is organized by topics. So if we go to the environmetrics, for instance, it has like a very complete list of different packages that deals with environmental analysis, and it has the list of the packages and what the packages can do, and so on. This is maintained by people that are contributors to the community, so this is an important person in ecology, and he maintains this page. Okay, in the last 5 minutes that we have, I want to finish. Thanks, Natalia. Running this code. I don't know how I will do this. Obrigada. Sorry. So we have here, we are creating here, let me do this. We are creating here a factor. So how we create a factor, it's using the factor function. So I'm concatenating different class for the animals. So the levels here, they are large, medium, small. This is the order that the default because of the alphabetical order. If I want to change this, I can use the function levels to change the levels. So now if I check the animal class, the levels are as I set, small, medium, and large. setSeed, this is a function I'm running here. This R stands for random, so I'm generating random data from a uniform distribution with 20 elements. So if we all run this setSeed, we will make our computers start at the random generation at the same point, and we should have the exact same matrix. So I'm creating here a matrix with this data in 2 different columns. I can create here an empty matrix with 4 columns and 3 rows. And then I create like a vector with 1 to 12. This signal here will create like a structure from 1 to 12. And I can put that inside my matrix. The matrix is created either like by column or by row, and this is controlled by this argument, by row true. I can create like a matrix with gem names now, because I have names for columns. I created a list with row names and col names, and I'm using that as gem names. So my matrix now has column and row names. I can assign that to an object. I can check the dimension. I can ask what are the gem names. It is the exact names that I set. I can create a data frame. So this is like this. I'm converting my matrix into a data frame. It is exactly, the structure is the same, but the class here is different. I have a data frame or a matrix. I can create a data frame using a data frame function. So I have a column that I'm calling name with the animals, a column weight with the weight, and weight class with the animal classes that we created. This is a data frame. If I want the second, for data frames, we will use row, comma, column. So here I'm getting the second row, first column. I can use a logical test instead of the row element that I want. So I'm selecting only the lines with medium weight. And if I can select only the actual weight of the animals that are in the class of medium weight, I can select the same rows with my logical test, and here I'm selecting the column that is called weight. I can create a list. I'm mixing 2 types of data here. I'm putting here animals df and animals. This is the first element. If I can check the order, animals list the second element. Ooh, I'm missing something. It is the vector of animals. So I have here, for selecting pieces of a list, we will use double brackets, okay, brackets. And the last part, this is where I want to get. You can follow the rest of the script later, but we will only, I want to talk to you about this part. Here is what we will do when we are reading a file. I have a data table. This is a CSV file, and I'm reading using the function read.csv. And the most important thing here is that I'm using here the relative path, never the absolute path, because we already told R where we are. So we will read the data. If we go here to our files. This is my project structure. I have here data. I have here raw. I have here portal data joined. This is a data of different species of small mammals. And I'm reading this just using the relative path. So from here, where I am, enter in the folder data, enter in the folder raw, and read my data. So that way, we have this function head. It will show the heading of the data. So if we run this, you're not seeing anything. But this is a data table with different columns. We have the record ID, the month, the day. This is record through time. So we have the complete date. This is a sample that was performed using plots. So we have the plot ID. We have the species ID. We have the sex, either if it is male or female. Sometimes we do not have data. This is empty. There are other information, the genus, the species, the taxa, and this is an experiment that has different plot types, and this is the column that says that. So we can read with the function read table. It is similar to read CSV, but then you have to, a CSV, if we can open here, like we can view. Oh, no, this is too large. But this is like a text file separated by comma, and that's what you need to specify when you are using the function read table.
What's the difference between... Can you hear me? No? Can you hear me? Yes?
Yes.
Yes? Okay.
Yes.
What's the difference between using NA or being empty? Like, we don't have this data.
Oh, that's a good point. People who work with data do not recommend leaving empty cells in your data set. So you can type NA if you don't have data, and R will read that as NA automatically. Or you can leave it empty, and then you can set empty values to NA inside R. But it really depends on what the data that you have and what is that. Something important is that we will talk more about that in the exploratory data analysis class, but it is important to be aware of the difference between 0 and NA, because sometimes we do not have the measurement and people type 0 and that's not correct. So sometimes it's 0 actually, but sometimes it's NA. It's always better to inform what you have in each cell. Do not leave it empty, but if it is empty, you can convert that into NA. So we will check, we will read surveys. We will read surveys using read table. It is basically the same data here. I can use the equal to see if they are all equal. It will return the exact same structure of each data table here. And if I want to check if they are all equal, oh my God, they are NA. We do not expect that. This should be all equal. We have a problem here. We have here different functions to inspect the data. And different types of selecting parts of the data. You can explore that later because we are already past the time. But in the end, we are using creating the end of the script ends with us removing the NAs in our data, and then we are writing the processed data in the processed folder, because that is a good practice, okay? The command here in 2010 line, this is a long script, we are creating we are asking if a directory called processed inside data exists, and if it not exists, I will create, okay? And then I can write the CSV. This is also good for reproducibility because I'm assuming that the directory exists, but I don't know if it exists in your computers. So that's what we have for today. So we talked about R and the idea behind it, and about object structures. We'll have time during class to go back to things that I was introducing here today. But the main idea for today is for you to start using R, opening your project or your script. We are already informed from what location we are, and then we will use in our script relative paths to read and write data. Okay? So that's for today. Thank you very much. See you tomorrow, and you can follow the script later. If you have any doubts, please let me know.
Do you listen